Good evening, everyone, and welcome to the ISI MSQE live session for 18th of April. Today, we'll take a look at question number 18 from ISI 2022 PA. So let me just open up the question for you. Question आपके सामने ये रहा. This is ISI 2022 PA. अब हम लोग देखें क्वेश्चन नंबर 18 को. What is question number 18? Consider the utility function 3x1 plus 2x2. 3x1 plus 2x2 is the utility function. It's a perfect substitute. Price is P1 and P2 both are positive. Money income is positive. Consider the optimization problem maximizing 3x1 plus 2x2 subject to 2x1 plus 3x2 less than equal to m. This equality will hold because both are good commodities. The associated Lagrangian function for this maximization is as follows. Okay. Then the equilibrium solution wherein we need to find out x1, x2 and lambda. We need to understand how to deal with Lagrange when we have a perfect substitute case. So in the case of perfect substitute, we can't equate the two slopes, right? So we need to think about how to use the Lagrange. So here you will be using the Kuhn-Tucker solution when I don't have tangency. So the Lagrange function is basically 3x1 plus 2x2 plus lambda m minus 2x1 minus 3x2. This is what we have. Just verify. Yeah. Okay. Now, the Kuhn-Tucker solution basically says that the first order conditions should be less than equal to 0 for optimization. Okay. So what will I do here? Del L del x1. 3 minus 2 lambda. Del L del x2. 2 minus 3 lambda. Okay. Now, one of them has to be equal to 0 in order to get to the maximum point. Okay. And the other one cannot be positive. It has to be negative. So please understand, let's pick a value of lambda here. So if I put both of them, what do I get? I get 3 minus 2 lambda. If I equate it to 0, lambda will be equal to 3 by 2. And if I put 2 minus 3 lambda is equal to 0, I'll get lambda is equal to 2 by 3. Now, when lambda is equal to 3 by 2, that is the first equation is equal to 0. What happens to the second equation? 2 minus 3 into 3 by 2. 2 minus 9 by 2, which is negative. So both the conditions are holding if I take lambda is equal to 3 by 2. If I take lambda is equal to 2 by 3, what happens to the first equation? 3 minus 2 into 2 by 3. 3 minus 4 by 3, it gives me a positive value. So if lambda is equal to 2 by 3, the second equation becomes equal to 0, but the first equation becomes positive. And if lambda is equal to 3 by 2, the first equation becomes equal to 0 and the second equation is negative. So lambda is equal to 3 by 2 will satisfy both these equations. Lambda is equal to 2 by 3 will not satisfy the first equation. It will come out to be positive. Hence, lambda is equal to 3 by 2 has to be the answer. Also, please understand, if lambda is equal to 3 by 2, what will I get? If lambda is equal to 3 by 2, it means that del L del x1 is the maximizing constraint. Okay, so this is something which is maximizing. So x1 will take the value. So m is equal to 2x1 plus the second condition del L del x2 is negative. Okay, so x2 will not take any value. It will take the value equal to 0. Okay, it will not be positive. So plus 3 into 0. So what will be the answer? x1 is equal to m by 2, which is the constraint where the equality to the first order condition is equal to 0. So that is the value that it will take, and x2 will be equal to 0, and the lambda value is equal to 3 by 2. So the answer here will be m by 2, 0, and 3 by 2. That's Bombay. It's not 2 by 3 because the first order condition is coming out to be positive. So it can't be. Okay. Also, it's a very logical problem. If I don't use the Lagrange, if I solve it in the usual way, how do I solve it? It's a utility function looking like 3x1 plus 2x2. So if I draw this, and the budget line is m is equal to 2x1 plus 3x2. So the budget line is something like this. This is m by 2 and this is m by 3. And the indifference curve will have a slope of 3 by 2. So this slope, absolute slope 2 by 3, this absolute slope 3 by 2. So where will I move this in order to maximize? I'll move it to the extreme value where I consume only x. Okay. So in order to maximize my utility, I will get the highest indifference curve when I consume at the x-intercept. And x-intercept is m by 2. So m by 2 comma 0 is my utility maximizing point given the budget constraint of m is equal to 2x1 plus 3x2. So this is question number 18. Thank you so much. I'll see you again in the ISI Live MSQE session. All the best. Happy studying.